Application management provides a wide variety of application services, processes, and methodologies for maintaining, enhancing, and managing custom applications, packaged software applications, and network-delivered applications. It encompasses server, cloud, PC, and web-based applications used in the enterprise. Application management is an enterprise-wide IT governance approach geared towards providing an optimal application performance benchmark for the organization while incorporating business and IT segments. The application management process includes application lifecycle management, application portfolio management, and application performance management. The key stakeholder in application management is application owners, application developers and managers, and application users. Let's first take a look at application lifecycle management. Application lifecycle management refers to the process by which IT and software development organizations create, deploy, and operate software over its full lifecycle. A typical application lifecycle management process that an enterprise may adopt includes the following phases. The first phase is gathering requirements. IT works with business units to identify the functional and business process requirements for the change or new application. The second phase is design. Based on the requirements, an application development team constructs the preliminary design of the software structure. The new software will impose resource requirements on the IT infrastructure, so IT analysts need to get involved at this stage. The IT analysts need to ensure that IT infrastructure resources meet the new resource requirements. At this point, a total cost ownership study is performed to identify development and ongoing support costs. The appropriate business manager and perhaps higher management must either approve the total cost ownership commitment or work with IT analysts and planners to adjust the project cost or overall business unit plans. The third phase is build, integrate, and test. The application development team develops and tests all the components and data flows. After final quality testing, management must sign off and move to implementation and deployment. The fourth phase is implement and deploy. With the final approval, the application team proceeds to produce the finished implementation and load module into production libraries. Further, the team provides user training and documentation so that the new application is used effectively and efficiently. The fifth phase is operate. During this step, IT staff monitor the application with respect to addressing changes in regulatory requirements, fixing flaws uncovered in the application monitoring service level, and measuring and reporting on application performance. The last phase is optimize. Once there is a certain level of operational experience, IT analysts monitor and evaluate application use and determine if there are any opportunities for optimization, such as its performance, capacity utilization, and user satisfaction and productivity. For applications that are not developed in-house, such as those provided by application and operating systems vendors, and open source applications, the emphasis of the application lifecycle management is on the last three phases. Next, we will talk about application portfolio management. So IT management is often viewed as a constant battle to put out fires on a day-to-day basis. Application portfolio management is a technique that applies cost-benefit analysis and other business analytics to the IT decision-making. It is meant to look beyond the day-to-day basis and evaluate an organization's IT infrastructure to decide when and where improvements should be made. The application portfolio management is concerned with taking an overall look at the entire application portfolio in order to make better decisions about when to eliminate, when to upgrade, when to replace or consolidate applications. Further, it must follow a structured and repeatable process for making evaluations and recommendations. The figure here on the slide shows the use of strategic matrix to illustrate the general strategy for assessing applications. The classification of each existing or contemplated application into one of the four quadrants is a useful aid in portfolio management. It supports prioritization and establishing a timeline frame for action. This table here on the slide lists some best practices for application portfolio management recommended in the report given by U.S. Government Accountability Office. Next, we're going to introduce application performance management. Application performance management is the practice within systems management that targets managing and tracking the availability and efficiency of software applications. Application performance management involves translating IT metrics into business terminology. It examines the workflow and the associated IT tools that are deployed to analyze, identify, and report application performance concerns to make sure that the expectations of businesses and end users are met. Application performance management is concerned with how well an application meets its intended purpose and performs as expected. An effective application performance management strategy consists of 5 steps. The first step is end-user experience monitoring. It is the most important step and captures data on how end-to-end performance impacts the user and identify any problem. It is related to studying the software and hardware components involved in application execution, as well as their communication paths to establish the potential scope of their problem. It is designed to discover the specific components that contributes to an application's performance. The third step is user-defined transaction profiling. This step involves examining user-defined transactions as they move across the paths defined in step 2 to identify the source of the problem. The objective is to determine what portions or layers of an application consume the most time. If the end-user response time is above a given threshold, this information indicates where optimization efforts should be concentrated. The fourth step is component deep dive monitoring in an application context. This step entails an in-depth monitoring of the resources and events occurring within the components discovered in step 2. The final step is analytics. It involves the use of analytics to crunch the data generated in the first 4 steps. It also entails discovering meaningful and actionable patterns, pinpointing the root cause of the problem, and ultimately anticipating future issues that may impact the end users. Application security needs to be considered as a separate security concern. The aim of application security is identifying the following: critical asset of the organization, genuine users who have access to the data, the level of access provided to each user, various vulnerability that may exist in the application, data criticality and risk analysis on data exposure, and appropriate remediation measures. As part of the application portfolio management, there should be an inventory or register of all applications with details concerning the application, including security-related aspects. This table here on the slide lists information that should be included in the register. As with other business assets, sound security architecture principles should be applied to business applications. The considerations are somewhat different depending on whether an application is built in-house or externally acquired. If an application is developed within the organization, it is essential to incorporate security into all stages of the system development lifecycle. We discussed all the tasks of system development lifecycle in detail in Chapter 8. Whether an application is developed in-house or acquired, a number of security measures should be in place, and they are listed here on this slide. When it comes to application security, internal security is important, but so is the external environment, including the host operating system or virtual operating system, hardware platform, and network connections. Other chapters in this textbook address the security controls that are provided by the overall enterprise system environment, which include the following controls here listed on this slide. As enterprises move applications online, both for internal use and for external users such as customers and vendors, web application security becomes an increasing concern. Open Web Application Security Project provides the top 10 application security risks, and they're listed here on this slide. The most important tool in countering web application threats is the web application firewall. And let's first watch a video about the web application firewall.
What is a WAF? A WAF is a security system that uses a set of rules to filter and monitor HTTP traffic between web applications and the internet. Just as a toll booth allows paying customers to drive across a toll road and prevents non-paying customers from accessing the roadway, network traffic must pass through a firewall before it is allowed to reach the server. WAFs use adaptable policies to defend vulnerabilities in a web application, allowing for easy policy modification and faster responses to new attack vectors. By quickly adjusting their policies to address new threats, WAFs protect against cyber attacks like cross-site forgery, file inclusion, cross-site scripting, and SQL injection.